So let's start with gradient. Let phi coordinates x, y, z be defined and differentiable at the points x, y, z. Then the gradient represented by this del symbol of phi. So it is gradient when we see these symbols. The gradient of phi, that's gradient. So in gradient, the gradient of one space is will be having this formula wherein we can get the partial derivative of phi or the given field. Partial derivative of phi with respect to x I hat plus partial derivative of phi with respect to y j hat plus partial derivative of phi with respect to z k hat. And resulting answer in gradient is a vector. Remember that the gradient is a vector while divergent is scalar. So basically they are the same, but the resulting answer of gradient is a vector but the divergent is scalar. So let's have this example. For number 1, if we coordinate xyz is equals to 3x squared minus y cubed z squared, let's find the gradient of the phi. And letter B, find gradient of phi at the points 1, negative 2, and negative 1. So we have to find the gradient. So the formula in getting this is to get the partial derivatives I hat with respect to x, j hat with respect to y, and k hat with respect to z. And we have to multiply by 3x squared minus y cubed z squared. So when we multiply it, we will be having partial derivative of 3x squared minus y cubed z squared with respect to x plus partial derivative of 3x squared minus y cubed z squared with respect to y plus partial derivative of 3x squared minus y cubed z squared with respect to z. So we get 6xy minus 0 I hat plus 3x squared times 1 minus 3y squared z squared j hat plus 0 minus 2y cubed z k hat. So the result will be 6xy I hat plus 3x squared minus 3y squared z squared j hat minus 2y cubed z k hat. So this is the result of the gradient of phi. So let's answer letter B. Find the gradient of the phi at points 1, negative 2, and negative 1. What we are going to do is simply substitute the value of x, y, z to the given gradient. So we have 6 times 1 times negative 2 I hat plus 3 times 1 squared minus 3 times negative 2 squared times negative 1 squared j hat minus 2 times negative 2 cubed times negative 1 k hat. So we have 12 I hat plus 3 minus 3 times 4 times 1 j hat minus 2 times negative 8 times negative 1 k hat. So compute the value and we have negative 12 I hat minus 9 j hat minus 16 k hat, and this is the final answer.